In this problem, we need to graph this logarithmic function here. And we need to identify and sketch the graph of the parent function, indicate how the parent graph is transformed, and then we need to sketch the function f of x and include its asymptote. So looking at our function up here, we can see it's a logarithmic function, and the parent graph will be log to the base 3 of x. So my parent graph excuse the bad handwriting, is y equals log to the base 3 of x. As the base that is 3, it is bigger than 1, so it is going to be an increasing parent graph. And we need a couple of exact points on there. And remember, with logarithmic functions, we put in the value of x. X is 1, so we're going to say log to the base 3 of 1 is 0, because log to the base b, as long as b is a valid base of 1, is always equal to 0. And the other point I always want to put in is the base. Well, the base in this case is 3, so what's log to the base 3 of 3? That is 1. So my two key points are 1, 0 and 3, 1. And a logarithmic graph has a vertical asymptote of x equals 0, otherwise known as the y-axis. So let's sketch our graph. First thing I'm going to do is put in a vertical asymptote of x equals 0. Then I need my two key points. The first one is 1, 0. So that means when x is 1, y equals 0. So I'm going to have this point here. And my second point is when x is 3, y is 1. So when x is 1, 2, 3, y is 1. So let me graph that point. So remember, the graph cannot cross the vertical asymptote, and it's the increasing parent, so it's going to have roughly this shape. So let's graph that in. So there's my parent graph drawn in a dotted line. So we've completed part 1. Now we have to look at part 2 and indicate how the parent graph is transformed. So let me write my equation for f of x. It is -2 log to the base 3 of x plus 3. So let's take a look at what this multiplying by a -2 outside the function does. -2 is really -1 times 2. The -1 is a reflection, and since it's outside, it's going to be a reflection in the x-axis. And multiplying by a 2 outside is a vertical stretch by a factor of 2. Now the nice thing is both of those effects can be done in one step. It can be done by multiply the y values by -2. That will accomplish the reflection in the x-axis and the vertical stretch by a factor of 2. And the other thing we need to look at is this +3 inside. It's inside, so it's horizontal. And adding 3 inside is going to shift it left 3. Remember, inside kind of does the opposite of what you think it's going to do. If you're not quite sure where this is going to shift it, set x plus 3 equal to 0, x equals negative 3. That means it's going to shift it to the left 3 units. And remember, we always do our horizontal shifts first, so that means this is going to be done second. And so I'm going to do this in 2 steps, otherwise I think it would be too confusing. So the first thing I want to look at is shift everything left by 3. So remember, my parent graph had a vertical asymptote of x equals 0. So if I take a point on the vertical asymptote and move it left 3, is it now on a different asymptote? Yes. If I take this point left 1, 2, 3, hopefully you can see the new vertical asymptote is going to be at x equals negative 3. So there's my new vertical asymptote at x equals negative 3. And now I need to take this key point and move it left 1, 2, 3. It's going right there. And now take this key point, 1, 2, 3. It's going to be on the y-axis. But notice the y value didn't change. The y value stayed at 1. It was just the x value that changed. And now I'm going to draw in my new graph. I'm going to still be a dotted graph because this is not the final graph. So there is my graph that is shifted left 3 units. And now the last thing I have to do is do the reflection in the x-axis, a vertical stretch by a factor of 2, which means I can multiply my y values by negative 2. But the first thing I want to do is figure out, has anything happened to the vertical asymptote? So I'm just going to take a point on the vertical asymptote here, where y equals positive 2. If I multiply that y value of 2 by negative 2, I get negative 4. Am I still on the same vertical asymptote? Yes, I'm still on the line x equals negative 3. If I take this point here, where y equals negative 1 times negative 2 is positive 2, I'm still on the same asymptote of vertical asymptote of x equals negative 3. So that is my final asymptote. And now all I have to do is take the point here when y equals 0. 0 times negative 2 is 0, so that point does not move. So that point stays the same. Now let's look at this point here when y equals 1. 1 times negative 2 is negative 2, so that point's going down there. So there's my other key point. So now hopefully you can see that my graph is going to have this basic shape. So all I have to do is sketch in the final shape of my graph. And so that is the graph of f of x.